I think at some point at everyone's life, we've looked up into the night sky and admired it. What you might not know is that when you look up at the stars in the sky, that nearly every single one of those stars has at least one planet around it. And what I want to do is I want to learn more about those planets. And specifically, I want to look for a planet that might be like Earth and that might have life. Something that we would really like to do is find another planet the same size of Earth that has oxygen in its atmosphere. Oxygen is important not just because it's something that we breathe, but it's abundant in the atmosphere because it's produced by plant life. So here on Earth, about 20% of our atmosphere is made up of oxygen, and that's all because of life on the surface of our planet. If we suddenly took away life on the surface of Earth, we wouldn't have any oxygen, which is why we refer to it as a biosignature, also known as a sign of life. But even though we want to look for oxygen in the atmosphere of other planets or on other stars, it could be very difficult to detect. And specifically, we want to look for the type of oxygen that's created by trees. Call it molecular oxygen. Because molecular oxygen can be very difficult to detect, many people have suggested using ozone, the byproduct of molecular oxygen, instead. A lot of people are familiar with ozone on Earth because it's what protects us from a lot of the damaging UV coming off of our sun. Ozone is something that would be a lot easier to detect in the atmosphere of a planet or on another star. However, the relationship between ozone and molecular oxygen can be very complicated. I'm leading a study here at the Instituto de Astrofísica de Andalucía to try to learn how to use ozone as a way to look for oxygen in the universe and therefore life. In the study that we recently published, we looked in particular at how other possible biosignatures could affect the relationship between ozone and molecular oxygen. We looked in particular at something called nitrous oxide, also known as laughing gas. Nitrous oxide and ozone have a very interesting relationship because very high up in the sky, in the main ozone level, nitrous oxide creates molecules that will destroy ozone. And if we have too much ozone destroyed, there'll be a lot more UV coming to the surface. Not only are we all going to get really sunburned if that happens, unfortunately it creates skin cancer and it can actually break apart our DNA. However, we found that if you had a lot of this extra nitrous oxide or laughing gas for planets around stars smaller than our sun, this didn't happen. Instead, there would be a lot more ozone created near the ground by this laughing gas or nitrous oxide. However, ozone near the ground is not a good thing for life. If you've ever lived in a city with a lot of smog, that's actually mainly ozone, and it's ozone that's created by things created by nitrous oxide. So in our study, we found that adding nitrous oxide to an environment, ozone would be destroyed if it was a planet around a star like our sun, but lots of ozone could be created if it was around a smaller star. But that ozone could be very toxic for life. Overall, trying to find another Earth will be a really difficult puzzle. And what we've done is just place another piece of the puzzle. In the future, we will look for more ways to understand ozone in order to use it as a biosignature to detect life in the universe.